how XPath is reshaping modern air power. Ladies and gentlemen, in episode 9 of XPath Live, we clearly presented by Brandon Sanders on stage in Washington, D.C. My name is Brandon Sanders. I am the president and co-founder of Shield AI. I am a mechanical engineer. I previously served as an engineering officer aboard USS Pearl Harbor, and I am a former US Navy SEAL. I have deployed twice to Afghanistan, once to the Pacific Theater, and once to the Arabian Gulf. 10 years ago, I founded Shield AI together with my brother Ryan and our third co-founder, Andrew. We started with a clear ambition to bring the most advanced technologies, the very best in AI and autonomy, to revolutionize air combat operations. We would do that by building a new generation combat aircraft, a breakthrough platform fully controlled by AI. And now, I want to introduce the person who turned that vision into physical reality, the inventor of XBAT, our head of aircraft. He joined Shield AI from SpaceX, where he led satellite engineering for Starlink and efforts on Starship, reporting directly to Elon Musk. Before that, he worked on Falcon 9 launch and landing systems, as well as the Merlin 1D engine. We often joke that with the name Armor and a career built around launching and landing everything, he was destined to bring XBAT to life. Ladies and gentlemen, please welcome Armor Harris. Thank you, Brandon. I think he is right about destiny. I never planned for the last two major projects I work on to both carry the word super. But that's how it turned out. As Brandon mentioned, XBAT represents a revolution in air power by delivering near infinite flexibility to our warfighters and an endless set of unsolvable problems to our adversaries. The design of XBAT is built around 4 core principles. First, vertical takeoff and landing capability. Second, true multi-mission capability within a single platform. Third, XBAT is designed from the ground up around an AI pilot system, not an AI added later. And fourth, a life cycle cost dramatically lower than traditional 5th generation fighters. In modern conflicts, we lose more aircraft on the ground than in the air. This has been proven across recent wars. Just ask the Russians. In Ukraine, Russian aircraft have repeatedly been struck while still on the ground, including strategic bombers, destroyed by drones that cost only a few $100s. In the recent India-Pakistan conflict, India struck 11 Pakistani air bases, leaving a large portion of Pakistan's air force pinned to the ground and unable to operate. Even here in the United States, we have spent decades building extremely advanced stealth aircraft with extraordinary survivability in the air. Yet all of them remain highly vulnerable on the ground to long-range missiles or low-cost drones. So when it comes to protecting our air forces on the battlefield, we really only have a few options. Option 1. We can build hardened shelters to protect aircraft. But the problem is, each of those shelters costs roughly the same as 9 aircraft. Option 2. We can rely on aerial refueling aircraft to base fighters farther away. But then you end up with a long chain of tankers just to get those aircraft into the fight. Option 3. You can build larger, more expensive aircraft with greater range. But that does not solve the cost problem. Vertical takeoff and landing is how you break the cost curve entirely. By removing dependence on large, centralized bases, we can disperse air power across the battlefield, closer to the front line, and dramatically complicate the adversary's targeting problem. XBAT is designed not only for vertical takeoff and landing, but also for ground mobility, achieving very fast turnaround times between landing, moving, and taking off again. If you can move within the time it takes your adversary to target and strike you, you can ensure ground survivability. Critically, XBAT does not require a fleet of aerial refueling aircraft because it launches from within the battle space itself. It also does not require dedicated air defense units or hardened shelters because it is always moving. At sea, our nuclear-powered aircraft carriers are some of the most valuable sovereign assets we possess. Deck space is extremely limited, and the air wing is incredibly powerful. Vertical takeoff and landing allows us to project air power from other ships in the fleet, dramatically enhancing carrier air wing effectiveness. For example, on helicopter carriers, we can deploy up to 60 XBAT aircraft, creating an air wing larger than that of many nations. We can also operate XBAT from smaller ships, such as littoral combat vessels. XBAT can even launch from non-traditional surface vessels, including commercial ships. This not only creates extremely difficult problems for our adversaries, but also dramatically expands launch and recovery options. With XBAT's range, the ship it launches from can remain outside the threat envelope, eliminating the need for large numbers of expensive defensive systems. And at this moment, Armor Harris moves to the most essential part, the design of XBAT. XBAT was not built around spectacle. It was built around physics, cost, and survivability. A simple propulsion system with a jet engine aligned along the central axis, requiring no complex auxiliary systems. A tailless design optimized for lift-to-drag ratio, reducing weight, extending range, increasing speed. An airframe that is inherently stealth-oriented, not for display, but to survive in modern air combat. And finally, the logic of vertical launch and vertical recovery, allowing XBAT to leave the ground like a missile and return like a living organism. No runways required, no fixed bases, no pilot in the cockpit. At this point, XBAT is no longer a concept. It has become a complete system. And that is where Armor Harris pauses. Not to conclude, but to open the next chapter. Because in episode 10, we will go even deeper. Every aerodynamic decision, every propulsion detail, every engineering logic that transformed XBAT from Doctrine into metal. If you find this video valuable and useful, please don't forget to like, subscribe to the channel, and turn on notifications. I'm Hai. Thank you sincerely for watching, and I'll see you in the next episode of